Hello, beautiful people. We are going to go through the pretest number 2 for your Unit 5 test. Your Unit 5 test is coming up in just a couple of days, so this is a great video to watch if you would like to know what's going to be on your test. Again, disclaimer, I am human, so if I make a mistake, just let me know. Also, we are on campus, so if you hear a loud bell or an intercom, please disregard that, and I apologize for the noise in advance. All right, let's get started. Find the inverse of each function. First step you need to do is rewrite this in terms of y. After that, you need to switch your x and y, but in this case, we don't have an x, we have an n. After that, you're going to divide by -2 because this is -2 times this right here. So we're dividing by -2. So we have n divided by -2 is equal to y plus 2 to the 5th power. I'm going to take the 5th root of both sides to get rid of that. So 5th root of n divided by -2 is equal to y plus 2. So we have 5th root of n divided by -2. Oh, excuse me, I'm going to subtract 2 both sides. So -2 is equal to y. Again, this is not an actual true y. This is the inverse function of what is given to us. So we need to use inverse notation. So it should be f, the inverse of f of n. Excuse me, the inverse of f of n. Okay, number 2, state if the given functions are inverses. You must use a decomposition of functions. You will not get credit if you use the other way. Okay, so you must use composition of functions. So what is composition of functions? It's f of g of x must equal to x, and g of f of x must equal to x. If both are equal to x, then yes, they are inverses. If they are not, if one of them fails, then you're done. Then the answer is no, they are not inverses. Okay, so let's start. F of g of x. So we have 5th root of x minus 3. So instead of x, I'm going to be writing the entire thing here. 3 plus x minus 2 to the 5th power. Then I have minus 3 inside. Then I have my plus 2 on the outside. Simplify that. I have a plus 3 minus 3. Then I have 5th root of x minus 2 to the 5th power. Plus 2 is on the outside. These undo each other, so I have x minus 2 plus 2. These undo each other, so I have x. Because this is equal to x, then we must continue to solve for g of f of x. So yeah, start writing g. This is 3 plus parenthesis. Now instead of x, I'm writing this entire thing, which is the 5th root of x minus 3 plus 2 is outside the bubble. I'm going back in here to say minus 2, and then to the 5th power. I ran out of room there. So then I have 3 plus 2 minus 2 is just 0. Then I have 5th root of x minus 3 to the 5th power. These undo each other. 3 plus x minus 3, x plus 3 minus 3 cancel each other. So therefore we have just x. Because both f of g of x and g of f of x equal to x, then your answer is yes, they are in fact inverses. Okay, let's continue here. Simplify each and state the excluded values. If you don't state the excluded values, you will be losing lots of points. Don't do that. Read the directions, follow the directions. Step number 1, when you're simplifying these, is always GCF. Pull out the greatest common factor and see if we can go from there. It'll be much easier that way, I promise you. For example, this one here, I see maybe a 5 can be pulled out, maybe something bigger can be pulled out. But let's go with 5. If you pull out a GCF and then you notice there are more GCFs you can pull out or other GCFs you can pull out, that means The one that you used is not in fact the greatest, so you need to pull them out even further. Okay, so 5 and 35, that's 7. Oh, you know what I just noticed? There's an n in each term. So I think I'm going to pull out a 5, save this, 5n. So then this is 7n squared minus 45 and 5 is 9n minus 10. And in my denominator, again, I'm going to try and see if I can pull out, I'm thinking 5n as well, because I'm noticing an n and an n here. So I have 5n, and then I have 3n plus 8. Here's the thing, you guys. Yes, you can cancel those out. Because this is 5n times, we also have this bar here, which is division. So 5n divided by 5n, that's just 1. But before you do that, this is where you need to identify your excluded values. Excluded values are values that would make the denominator 0. So you can split these up, and I'll do it on a separate sheet of paper here. But you can't split them up and set them equal to 0. Solve for it and then see what they do. What I mean by that is 5n equal to 0 and 3n plus 8 is equal to 0. So then solve for your variable. So n is 0. This one is subtract 8. 3n is equal to negative 8 divided by 3. N is equal to negative 8/3. So n cannot be 0 and n cannot be negative 8/3. If n is either of these values, that means our denominator would in fact be 0 and therefore the world will explode, right? Because we can't have a 0 in our denominator. So before you cross anything out and after you factor, so after you factor and before you cross anything out, state your excluded values. So I'm just going to state here, n cannot be 0 and n cannot be negative 8/3. Now, I truly am not too picky about the order if the negative comes first versus the 0 versus the positive. As long as you state them, I'm very happy about that. So once we've stated the excluded values, then I'm going to proceed to cross that out. They undo each other. And now we're left with these two things. Now, we need to continue to factor, okay? This one here is linear, so the exponent on that n is 1. So this denominator cannot be factored any further. Okay. And then this numerator can in fact be factored, and we're going to try. So I have 7 times 10, that is negative 70, and I'm going to use my diamond method. Negative 9. Okay, so now I need two numbers that multiply together to give me negative 9 and then give me 70. So you can, off to the side, do a little mini factor tree and see what those values are. So 7 times 10 is 70. 5 times 2 is 10. So I need some sort of combination of that to give me 9. Let's see here. 7 times 2 is 14 minus 5 is in fact 9. So 7 times 2, so I'm going to say 14 and 9. 9 down here is negative, so we want a negative value on the 14. Now, I'm writing a fraction. In the numerator, you're going to put your leading coefficient. So this 7 goes on top. After that, you're going to simplify. I'm going to shift everything down here. You're going to simplify the fraction, but you're going to leave it in a fraction form. So what I mean by that is I can simplify this as 1 over negative 2. Keep the negative where it belongs. Don't move it. This fraction cannot be simplified. So when you go and write your fraction here, write your factors, the numerator is going to be the leading coefficient. Oh, I don't know why I just wrote a 5. That's weird. Let me get rid of 5. I think I was looking at that 5. I don't know why I did a 5. Okay, so the numerator for this fraction is your leading coefficient, so it's just 1. Then you have x. The denominator is your constant. Again, leading coefficient and your constant. So that's in our numerator. Then we need to rewrite the denominator because that was not able to factor. And then we look, is there anything that we can cancel out? And everything is factored. It doesn't look like anything can cancel out. That's weird. Oh, you know what? I found another mistake that I did. See, mistakes happen. We're all human. I should have written down 5 here, not 9. I don't know what I was thinking. That should have been a 5. So this is a 5. So here, 7 times 2 is 14. What's left over is 5, so this should have been a 5. Okay, and then this, again, still doesn't factor, so we are left with this. So here's our simplified version. Here's our 2 excluded values. Okay, number 4. Again, factor, and then factor some more. The first thing I'm noticing is it is a division problem, so we need to do KFC. And then one super thing I want to address on this problem is your excluded values. On your quiz and on the review, I'm noticing some hiccups when it comes to stating excluded values for division. So we'll mention that in a little bit. Okay, so factor everything first. Let's see what I have here. Does 9 go into 63? Yes, it does. So I'm going to pull out a 9, and I'm going to pull out an x. So I have x plus 7 left over here. Again, I'm going to pull a 9x out, and I have a x plus, oh, what is this, 5 left over. Here, we need to factor. Don't change anything yet. Don't apply KFC yet. Apply KFC later, and I'll show you why. First thing is just factor. This one here, let's see, 2 numbers that multiply to 40. That is 8 and 5. And then does 8 and 5 give us 13? Oh, it does, and both of them are negative. So x plus minus 8, x minus 5. And this one here is the difference of 2 squares. So you should know this. This is one of your factoring rules or patterns, factoring patterns. So this should be 5 minus x and 5 plus x. Okay, here it is. The reason I do not want you to cancel anything out or apply KFC yet is once you are done factoring, you will identify all of your zeros. Okay, again, look at your denominator. You are stating your excluded values. So anytime you see a variable, draw an arrow and identify your excluded value. So x cannot be, what is x cannot be here? X cannot be 0. X cannot be negative 5. X cannot be 5. And x cannot be negative 5. So I'm not going to write negative 5 twice. I'm just going to write it one time. But this is why I don't want you to apply KFC yet. Once you've identified your excluded values, then apply your KFC. So I'm going to rewrite them. Let me change the color so that way we can keep things a little bit more organized. Okay, so I have 9x times x plus 7 all over 9x times x plus 5. Now here's the KFC. We're going to multiply by the reciprocal. So I have 5 minus x, 5 plus x, and x minus 8, x minus 5. Okay, you know how I mentioned you have to state the excluded values? Because you flipped your fraction, there is a new denominator that you have to worry about. So this one here is also part of your excluded values. So what does x have to be in order for this to be 0? It needs to be 5, which we already have. So what does x have to be in order for this to be 0? It needs to be an 8. So again, your original denominator, and after you apply k of c, you look at the denominator as well. So before k of c, you're basically on the second fraction finding excluded values for the top and the bottom. But really, you're finding the denominator because you are flipping this fraction. Okay, now that we've identified all of our excluded values, not just some, we get to go to our happy place and cancel stuff out. 9x, x plus 5. This one here, I can rewrite it as x plus 5 because it is just positive in addition, so I get to cancel that out. Do I have an x plus 7? I don't. But then I'm looking 5 minus x and x minus 5. Those are opposites of each other. So what I'm going to do is I'm going to make it work. On this one here, I'm going to factor out a negative 1. So what I have left over is x plus 7. I don't have anything in the denominator. I'm just going to write a 1 just for right now. And then I have 5 minus x. I'm going to factor out a negative 1. I have x minus 8. And now I have is negative x, or I'm going to flip it as well. So I have 5 minus x. Because this is multiplication, all you have to do is just write that negative 1 out in front. Okay? You don't have to pull out a negative out of here. It's already multiplication. Just factor it out, write it out in front. Then, because I was able to do that, we get to cross these out, cancel these out, undo them. And so what do we have left over? We have x plus 7 times 1. All of these are just 1. And then in our denominator, I'm going to multiply that negative 1 in. So I have negative x plus 8. So then our final answer is x plus 7 all over negative x plus 8 with our excluded values for all of our denominators, 0, negative 5, 5, and 8. All right, I may have to do this on a separate sheet of paper because I'm looking, we're going to be running out of room here. Maybe, maybe not. All right, step number 1, GCF. Do we have anything to factor? We do have a lot to factor, but I'm noticing that my original gut feeling of factoring out a 2 is wrong because of this 11. Can't factor out a 2 out of 11. So let's go back to diamond method. 2 times 12 is 24. And then we need negative 11. So two values that multiply together to give me 24, but when I add it, gives me negative 11. I'm thinking negative 8 and negative 3, 8, 9, 10, 11. Double checking my math with my fingers. All right. And so then again, write your leading coefficient in front. Simplify that fraction, but leave it in a form of a fraction. So then we have here, what do we have here? X minus 4 and 2x minus 3 instead of that. Again, once you have factored it, it doesn't state it, but now would be the time for you to state your excluded values. But it doesn't ask for it. Make sure you are reading the directions. Don't do more than it's asking you to do because then you're just going to be wasting some time. Maybe some mistakes can happen. So read the direction, take your time, make sure you're not doing too much and make sure you're not doing too little. Okay. Because this is a subtraction, I'm going to rewrite it as adding a negative. So I know that my negative belongs to my 5. Okay, again, subtraction. So adding and subtracting fractions, you need common denominators. Common denominators. The easiest way that I know how to do it is I'm looking at this denominator. And what is it missing that this denominator has? Okay, again, let me repeat that. I'm looking at my denominator for 2n over x minus 4 and 2x minus 3. So I know that this denominator consists of x minus 4 and 2x minus 3. But this denominator also has a 3. You see that it has a 3. just times 3. It doesn't have anything. So although this one includes a 3 on the inside, it doesn't count. We need a 3 on the outside. So I have to multiply this by 3. And then I'm looking at this guy. Okay, I'm looking at this guy. This is only a 3. So what is it missing that this denominator has? Well, it's missing an x minus 4 and a 2x minus 3. So your common denominator has to be this guy here. Okay, so once you've identified what your common denominator must be, then you have to multiply your fractions in order to make it work. So what I mean by that is I have, let me draw a little line here so I know these are separate. So my 2n and my x minus 4, 2x minus 3, they all need to be multiplied by a 3 because I'm looking for the need, excuse me. I'm looking for this denominator. I need this denominator. So in order to make it work, I need